Hello and welcome to a tutorial for Vexx. In this tutorial I'm going to be drawing a 5-veined iris. Not that the world needs another tutorial on drawing irises, but in this case I want to exemplify some of the tools that are available to you now in Vexx for animating a mechanism so that you can figure out where things fit. There's a couple items I'd like to go over though before I start, just that are important. Since Vexx was put out, there are now two types of AutoCAD output. You'll find the AutoCAD 2015 output is compatible with some programs, where Fusion 360 would prefer AutoCAD 2009. Also, if you're going to be designing mechanical mechanisms under scaling, you're going to want to check lock circles and lock arcs. If you try to stretch a set of contours or a group in Vexx, if they have a circle in them and these are not checked, the arcs and circles will be changed into Bezier curves, and some programs seem to have problems with the Bezier curves. Another thing that you're going to want to worry about is this polyline import tolerance. Set it to about 0.005 millimeters. This is a tolerance which says when to change a shape into a straight line as it imports. It gets rid of noisy inputs, but if it's set too high and you import something like a gear, it could strip the teeth off of the gear because it would see them as noise. So keep it as a low number. That's about the only thing that you need to worry about in terms of settings. The only other thing I want to mention is just a quick recap on how what are entities, contours, and groups, because I don't believe groups was out when I did my last video. Let's draw a little box here. Now this box is made up of entities, 4 lines. The entities connect automatically into a contour, and Vexx likes to connect everything into contours. So no matter how you draw, when it sees itself able to create a contour, it will. Now if I select a contour, we have a very important point up here, which is the rotational dot. This rotational dot, when turned on and is green, tells Vexx to rotate on that point, not on its center of mass, which is the normal rotation point. This rotation point is used for other items as well. When you do things like array copying and so on, it will accept these as the center point. Now, when I go back, you'll see it's turned gray again. Contours don't have any memory. They're quite dumb that way. If you group something, however, it has memory. If we go to Edit, Group, you can group any group of lines, contours, together into a single group. This group now will remember where I put its rotational center, even if I'm selected away and doing something else. This rotational center will also be copied or array copied to other groups when you deal with adding groups together. If you add 2 groups together, you will lose information such as the rotational dot and linkage information. And we'll go into linkages as I draw the 5-point iris. Linkages are new, and they can be used and extended to things like hypocycloidal transmissions and to animate gears that you've imported from Garrotic using the Garrotic import menu. Alright, so all that having been said, we want to draw our iris. So I'm going to start by drawing a 2-point circle. Now we'll automatically snap to 0 if we're close to 0. And if we want to get a particular diameter, we can type it in. Now I want my mechanism to be about 150 millimeters around to fit into a board. So I'm going to tab down to the diameter tab and add 75, half of that end radius. And this will be my radius circle for creating our iris. Now each of the iris leaves that are in here, we want them to have a swivel to swivel on. So we're going to use the same 2-point circle, and right up here at the intersection of the circle and the center line, I'm going to enter a 0 in the X, and then I can just click on the circle, and now I can create a circle of 6.25 millimeters, 1/4 inch, so that I can use a 1/4 inch swivel. Now we need 5 veins, so I'm going to array copy that circle 5 times with the circular array button. Now here you want to take a look and make sure that your center of rotation is 0, 0, which in this case is center of the screen, and 5 copies over a sweep angle of 360 degrees. We say OK, and we get our 5 leaf circles. These are the swivel points that our veins are going to swivel on. Okay, next we need to create the shapes of our veins. Now veins are created with the intersections of 2 circles when you're doing a 5-vein system. So we're going to create a circle from the center of our pivot and snap it to the center of our main radius circle. And we're going to do that to these first two pegs. Now, one of the reasons you use 5 vanes to do one of these, certainly for your first one, is because the way the mathematics combines to make perfect swivel points for the vanes and so on. So trust me, if you're going to build one of these, build a 5 one first. You'll see the difficulties when you begin to make 6, 7, and so on. So I'm going to select the ruler and measure the distance from our swivel point to the edge of this circle. Now when the cursor changes, it's actually giving you the measurement to the closest object. You can see that the circle icon is on and the line is only going to the circle. So if you touch the circle, you'll find that we're about 6.5 millimeters away from our central pivot. So I'm going to draw another circle, centered at 0, and about 6.5 millimeters above above the center, or above the top of, this swivel point. So somewhere around here. It's not important exactly how far, but this is going to create your swivel circle. So now we can see our vane is this shape here, the one side of one circle, and this shape here, which is the other side of the first circle. I'll clip away the portions that don't belong to our vane now, such as these lines here, and we'll just clip everything away except for the points which belong to that vane. Now when you're using the trimmer, it shows red what it's about to remove, and it is possible for the trimmer to screw up just as it did right there. So be handy with a Control Z in order to undo that problem, and we can see that this will not seem to cut at this point. And the reason for that is because Vexx has already selected these as being a contour. You can see they're all lighting up red, and some self-intersections can be missed. When this happens, remember that you have several options to your trimming. If I push the Control key, I will remove the entire entity. If I push the left Shift button, I will remove only from the scissors forward, and if I push the right Shift button, I'll only remove backwards. So you can see here that gives me a result where I can get close to the proper trim, so I'll select that. I'll continue to trim away the rest of the items that we don't need for this vane. And now when you come up, a new contour has been selected and you may be able to trim it properly. I can't in this case because I still have an overlapping self-intersecting contour. So I'm going to use my Shift key, zoom in, use my left Shift to click very close to those 2 points. And now I'll hit Escape to get out of my scissor tool, and when I select contour, we can see that the start doesn't quite hit the end. So I'm going to lift up the end and move it to the start. That is a move of probably 1/10 of a millimeter, so it's not significant, and it's a good way to close a contour which is not closing for you. So here we have our first vane. But you want to round off the edge of your vanes so that this can tuck in without interfering with the next vane. So I'm going to draw a circle centered on our pivot point of this vane until it touches the contour of this curve. And now I'm going to go back to my scissors, and you can see that I cannot, although it did intersect at this point and the scissors now recognize that, we're not there at the top point. So again, we'll use our trick of putting the scissors where we wish and then hitting the left Shift key, and it will remove the appropriate portion. I can now go up and zoom in, hit Escape to get rid of my scissor tool, and move this down to an intersection point. And you can see that the circle glows green when you are on the intersection point. This won't affect our end curve in any significant way at all. And now we can take our scissors and trim off the interior of that curve. And there is what we would want for a vane. Now we need something to pull that vane out from the center, so I'm going to add another circle right here. And it's not real important where you put it, but you should keep it about equal with the radius of this second circle so it stays out of your way. But again, it's arbitrary, so you can just pick a point enter a circle, and I'm going to make that a 6.25 millimeter circle because I'll just shove a wooden dowel in there. Okay, so there's our vein. It's complete. Let's hit escape to remove all tools, and I'll do a drag select, and I'm going to group that with the edit group control. You can see it's changed color. Now that it's a group, I'm going to give it a rotation point because groups are smart enough, as I said, to remember rotation points, and we'll put it right onto its swivel point. Now we're going to need 5 of these veins, so I'm going to select that vein and go to array copy again, and here we're going to do 5, and make sure that your center of rotation is 0, 0 at the center of the screen, and we'll do 5 even veins. Now once you have the veins, you'll find that they're all groups of their own already, and they already have a swivel point, rotation point set at their swivel, because group, when it does an array copy, it will copy things such as the rotation center and move them to the right coordinates. So here we have 5 veins. At this point, we'd like to know how these veins move, so I'm going to select the first vein and go to properties down here on the bottom of our bar. And when you click on a group on the screen, when it lights up, the name up here will show up and tell you which group you've selected. So up here is unnamed group 41. These numbers at the end are random numbers, simply as internal identifiers to make sure that there's no collisions. You can rename that now, and let's call that vein 1. And now let's go through them and name them vein 2 through 5. Okay, I just skipped that part rather than bore you to death. And now that they're named, we can start to set some linkages between them to give the program an idea of how to deal with them. I'm going to select vein 1, and up here I'm going to hit add linkage, and I'll tell vein 1 that it needs to control 2, 3, 4, and 5 with a rotation ratio of 1. This tells it that if vein 1 moves 1 degree, so too should 3, 4, and 5. Now that that's set, you can test that by selecting the vein and taking the rotation dot and moving the vein. And you can see here that we're missing properly, we have no interferences, and the veins are moving just great. Now, this is not a simulation. You're actually asking the program to rotate them all. If I were to release my mouse button, they would lock in that position, and their actual coordinates have rotated to those positions. If you like to keep things at 0 and you don't want to actually move it, and you don't want the pain of having to find exact 0 in order to lock them back to 0, press your control key, and when you release your mouse button, no rotations will take place. They'll simply go back to where they were. Now, should you forget to do that and you rotate them out and release your mouse key, and all your veins are now in these locations, you could always use Control Z to go back as well. So now we have veins which are linked to each other. They move properly. We know that these pivots, these points on the veins are pivots, and these points here are going to be used for pins to move the veins out in a proper fashion. So in order to move these veins out, we're going to need a ring, a control ring. So we'll go back to tools at this point, and let's create a couple more circles. Actually, before we create the circle, let's move the veins into an open position. They will be open at approximately this point. So we need a circle which is going to surround these, which will be the inner part of our ring. So I'll select 0, and I'll draw a ring out to about here. And there's our inner ring. We'll need another one for the outer part of the ring. This will be the largest point on our mechanism. And here we are. And it has a radius of about 65 millimeters. So we're about 130 millimeters complete mechanism size. So in order to create our ring, let's select it. I'll hit escape to exit all tools. And we'll select that outer ring. I'll hold down the shift key and select the inner ring so that they're both selected. And I'll select edit group. And we now have a control ring. But we need to see how this control ring does its movement, and we need to have a slot in it to control these veins with the proper amount of rotation. Now, how much rotation it takes to close the vanes is really a design consideration for you at this point. The less you need to turn the ring in order to open or close these vanes, the more power it's going to take to close the ring. If we just take for granted that it's a certain amount, a constant amount of power taken to open or close the vanes, that power requirement is going to be divided into how many degrees it takes to open them. I use about 40 degrees or so, but the shape of your slot is going to depend on exactly how much you have to turn that ring. So we need a way to measure that rotation. So let's take a small circle and draw it on our ring at a convenient 0 spot, which we can use for measurement. Now we want to add that to our ring group. And an easy way to do that is to select that contour, hit Shift and select the outer ring group, and then use this button down here in the group operations, which is Add Contours to Group. This had the advantage of adding a contour to a group without changing its parameters. The group will retain its center rotation dot, which I hadn't set, and I'll set now to 0. And it retains any linkages and so on in the group. If you combine two separate groups together or contours with more than one group, you will lose that information as it won't know which group to use, and you'll end up resetting it. Alright, so now we have a way to measure how far we're going to move this ring, and we now need to find out what kind of slot would fit these control pins in order to open or close the ring. So what we'll do is create a circle to identify the start of the slot. We'll assume right now that the shutters are open, and we'll just draw a circle large enough for us to recognize at any time. Now I'm going to select that circle and the ring and do another add to group. Now we can rotate our ring by an appropriate amount that we figure should be used to close this device. Let's say, for example, we rotate our circle this far. At this point, our shutter should have closed. So I'll grab our first shutter, which is linked to all the other shutters, and I'll close them. Now, if you want to be sure that you're absolutely closed, you can zoom in, and you'll see that we're a little bit off. Using your page up and page down key will do incremental and small rotations. And the closer you are, the smaller the rotation they will do, to the point where you can get them close enough that the measurement is immaterial. So here we are closed, and we're going to make another ring point on this location. Now we want to also attach that to this ring, and as you can see, they're almost in a straight line. However, sometimes there can be a subtle arc to this slot, and we want to find out what that arc is. So I'm going to hit Escape to cancel my tools again, select this and the outer ring, and do another Add to Group. Now at this point, I want to be able to find the location in the center so I can find the arc that this control slot should be at. Now, in order to connect the ring to the vanes and make them move, we need to figure out what a gear ratio is between the two. There's two ways to do that. One is analytical and the other one is graphical. So let's take a look at the analytical. If we grab a ruler and we measure from the center of the object to our control pin, we can see it's 22.37 degrees up. We'll note that angle. That's the angle that the ring rotates when it goes from closed to open, 22.37. The next angle that we're going to want is the angle from the center pivot of this vane, which is normally sitting at minus 90 degrees to its tip, and we know that the tip is going to move out to the edge, and that goes to 138.75. So if we subtract 90 degrees from 137.9, we're going to get 47.9 approximately. Now if we divide 22 into 47.9, we get 2.1412. Remember that number as our ratio. Now we can go to our Projects tab and select our ring. And we can see it's called unnamed whatever at this point because we've regrouped it several times. So we'll change its name to ring. And with ring selected, we'll add a link to vein number 1 with a rotation rate of 2.1412. And now when we go back to our ring, it should open and close and end up in the appropriate rings. And you can see that it does. Here's the closed, and the ring up here at the top of the screen is in the proper position. And when we go to closed veins, the second ring is in the right position, so our ratio is correct. Now let's take a look at the graphical way of doing that, because sometimes it may not be entirely clear depending on the mechanism exactly which two angles to check for a gear ratio. So if we imagine that we don't really know what the gear ratio is, let's select the ring and the vein, and we'll change that to a gear ratio of 1, which is what the default would have been. And now if we rotate our ring so that this control ring comes back to 0 and observe what happens with the veins, we can see they only half opened. This means that the number we've entered as a rotation ratio is somewhere around half of what it should be. So we'll take that back to its 0 point, and we'll enter a ratio of 2, which should bring us closer. And you can see that when we hit 0, the vein is just not quite opened all the way. If we had gone a little bit further, we could have opened it. So it's higher than 2. Go back to 0, and we'll put 2.2. At this point, you can see the vein opens a little bit too much. So the normal course would be go 2.15. And at this point, you'll probably find you're close enough. It would be hard to tell the difference in those decimal points. So there's the two ways to find the rotation ratio of the ring, and it's important to find it before we set the middle point of this control arc. Okay, so now we can move our ring to about halfway open, and that would be a position halfway between the two extremes of our control pin. So if our control pin at the top is there, and we want an equal weight between the two, we could say that is our halfway point there. So let's draw another circle, centered on our control pin. All right, now we have 3 circles which define the arc or line, which is going to control it. The shape of this slot will really depend on how far you're going to run it in your control. So now I will choose a 3-point arc, and I will go from center circle of the outside to the center circle of the inside and conform the arc to the center of the middle one. And in this case, it's a straight line. We could have just drawn a line. So with that in mind, we can now take our line, or we can select that contour we just put on, and we'll hit delete and delete that. I'm going to select the ring and ungroup twice. And the reason I'm going to ungroup twice is to remove the circles that we've drawn from the group. So we'll ungroup, and you'll notice it says ungroup to previous groups. And so one at a time, these circles will ungroup there. And now we can unselect everything, select those 2 outer circles and destroy them. We can select our curve and do an offset here, and I'll offset at 3.125 millimeters for a 1/4 inch slot. We can now deselect those, select the center line, and delete it. So now we have our control point, our control ring for control slot for each of our veins. So now we can do a circular copy of this with 0, 0 as center, and all of our slots should line up. So the final thing to do is to group all these with our ring by selecting them all, selecting the outside ring at the same time, and selecting group. So now we're going to go back and take a look at our ring. We did so much ungrouping that we no longer have the data that we had in it before. So we're going to have to rename that to ring and move the ring to the top priority. Add a control to vein 1, 2.15, and we Should be able to move our ring to 0 and back out to full. So there we have the designed ring with its control, and everything appears to be good. So we can just machine our ring now, machine our vanes, and the pivot points of our vanes need to be machined into a board to hold those. But we also need something to hold the ring. So at this point I also add a slot for the ring. That can be done by just starting to add some points to the ring to be supported on the back plane. Let's give it a ring here of 6.25. We'll copy this ring on an array copy 5 times. Now if you're not going to use this timing ring for a pin, I am going to use it, so I'm going to retain that and remove this 5th one so it's not in my way, and I'll support my ring only on 4 points. So these 4 points we will group together on their own. These will be the support posts machined into the backboard, and in order to support the ring itself, I'm just going to make something that is a ring which is fairly large, and I'll show you that on the actual item. But in order to do that, I'm going to open our vanes all the way, and it would be nice if those vanes hit something to stop them. So I will make a ring that's large enough that if they went too far they would hit it, and these will be the support posts on the back. So I'm going to select one and the other. I'll do an array copy of that large one, and now I can select all the groups. Group those rings together into another group. We can delete this ring as I don't intend to support the ring in any more than one spot. And now we need a slot for this backplane pin to run in. So we'll make a little circle at the top here. And sometimes you need to zoom in. Like here, you'll notice I'm not drawing a circle, and it's because I keep snapping to circle center. So you may have to zoom in order to give yourself the freedom to draw a circle. We now move we're going to group that ring. Now we'll just rotate our device so that the shutters are open. Sorry, I messed up. I meant to group that ring. Select the ring. And select our outer ring. And rotate them both so that we're closed. So now we need to draw an arc between these 2 points. And we'll do that first by finding proper center for them. Just draw temporarily a circle out to here. We will make an arc from the center of this circle to the center of this circle and snap it to that circle, to the large circle. We can now select the large circle and delete it. And if we offset this arc by 3.125, we'll have a 1/4 inch slot for the ring to run on. Now select the center and delete it. We can select our little marker point and delete that. We can array copy this 5 times. We're not going to use this particular one. And now we can select those and add them to our ring. And that's it. We now have our back plane, which is these 4 dual level pins. They come up to just under the ring and then follow up with a 1/4 inch pin through the ring. The ring is on the ring is driven on the slot on the center of that pin, and we have a device that runs. But you'll notice we're back to having vane 1 drawing on its own. And this is because we've regrouped and the ring is at a low priority again. We're going to move that priority up, and then everything will simulate normally. So that's how you design a 5 vane iris without really having to do any calculations or complicated angles. So that's it for this tutorial. That's how I draw an iris. A couple small points that I'll mention. Linkages can be to any depth or length they nest. So you can have as many linkages, and linkages continue on just like the linkages in Gearotic do. So you can make them any length that you wish. Another thing is if you copy and paste your groups and move them about, just in the odd event that you have a 3D printer and you wish to 3D print them, don't forget you also have an extrude button here where you can quickly create an extrusion, an STL, and send it to your 3D printer for printing. All right, that's it until next time. Have fun.